Part 2 of solving inequalities. This time it's going to be compound inequalities, two-part inequalities. So let's look at a couple number lines. We've got one that's got the middle part shaded, or a chunk in the middle shaded, and then we've got another one that's got two parts of it shaded. This time, the part that's shaded is in between two numbers, and on the one side you can tell it's a less than or equal to because it's got a shaded in dot, a solid dot, and then on the other side it's got to be a less than because it's got an open dot. So it's saying -2 is less than the part of the graph that is true is less than or equal to 3. So the answer, the solution that this graph is representing, is -2 is less than x is less than or equal to 3. The other one, it's got two separate parts. It's got one part where x is less than or equal to -3, and it's got one part where x is greater than or equal to 1. So it's the two ends there. And so that's an OR graph. The first one is an AND graph. I have a silly little way to remember it. This one's kind of got three parts, even though it's really one part. But you can kind of see that it's A and D, the A or the end, the D is the end, and the N is in the middle. And this one's just got two parts, O and R. Silly little way to remember it. Why is it really that way? Well, if I just take one number here that's on this one, like -1, that's one of the parts of that shaded in part, and I stick it in that inequality, -2 is less than -1, that's true. And then stick it in the other part of the inequality, -1 is less than or equal to 3, that's true. So I can have one number, a single number, that satisfies both that part and that part. It satisfies both parts of the inequality. So it's AND. This one, if I take one of the numbers that's in part of the shaded part, I just pick -6, it's over there, and I put it into that inequality. That's true. But if I stick it into the other part, that's false. That doesn't mean that -6 isn't the answer. It means -6 is part of the answer, but it only satisfies half of the whole big inequality answer, only one of the little inequalities. If I pick 4, some number on the other side, that satisfies the other half. The 4 is greater than or equal to 1, that's true, but 4 is not less than or equal to -3. That doesn't mean that that's not an answer. Again, that's why this is an OR graph. Any number that's part of the answer only satisfies half of that big long statement, that OR statement. Right? Only satisfies this or that. Only one half. So, what are we going to do with this? Let's solve some. Solve and graph the solution on a number line. Same instructions as last time. So here's our little compound inequality, and you can just tell by looking at it it's going to be an AND graph. Kept a nice clean copy of our problem, and it's really two problems in one. There's our x, so we've got to focus on that. That's in the center. There's that half, that's -10 is less than 3x plus 5, but that 3x plus 5 is also part of this other inequality. So you can see we've kind of got two going on simultaneously. You might have done these in the past by separating them. We're just going to do them all attached. So we're trying to get x alone, so we're going to subtract 5 from both sides. But in this case, it's not both sides, it's all three sides. From all three chunks of stuff. From the center chunk, from the right chunk, and from the left chunk. That's going to get us one step closer to getting x alone in the center. So now I have -15 is less than 3x is less than or equal to 3. I have one more step to get x alone. And so now I've got x is in between -5 and 1. -5 is less than x is less than or equal to 1. So that's my answer. To graph it, I think these are easier to graph because you just pick up that big old inequality and put it onto the number line. I put the correct dots on the numbers, and then I know I just shade in between. As long as your smaller number is on the left, you're okay. Let's test a number in the middle there. 0 is between -5 and 1, so let's try 0. -5 is less than 0, is less than or equal to 1. That's all true. Try another one in between. -5 is less than -1, is less than or equal to 1. That's true. So all those numbers in between are true. If we tried something outside that center bar, it would be false. Okay, here's another inequality for us. This time it's going to be an OR. And notice it really does look like two separate problems. We just do them independently. It's pretty darn easy. So we can solve these all day long. We got x is less than or equal to -3. So that's part of our answer. And then we just go back and solve the other one. Same old rules. Get rid of the addition or subtraction thing first. So we've got the two parts of our compound inequality. X is less than or equal to -3. X is greater than or equal to 1. And we know it's going to be an OR because one answer will not satisfy both of those. So we go to put it on a number line. We put our -3, we put our 1. Put a dot at -3, it's closed dot because it's got the equal. And then let's try something to the left of -3. -4 is less than or equal to -3. Yep, that's true, so we're going to shade that way. We could try something in the middle. It would be false. I'm not going to write it, but 0 is less than or equal to -3. No, that's not true. So we're not going to shade in the middle. And then 1, it's going to be that way. So that is compound inequalities.